So first section we're going to look at is 5.1. And we're going to look at this idea of systems of equations. Okay, we're going to spend quite a while on systems. This academic week, probably the next 2 academic weeks.
Yeah, pretty much all of third quarter.
Yeah, we spend a while on this topic.
Third quarter.
Yeah. So there's different. We're going to talk about what a system is. Okay, and then we're going to show you guys different ways to solve systems. There's graphing, which we're going to look at that today. There's other methods called substitution. Okay, we're going to spend a couple days on that this week. And then there's another way we're going to look at called elimination. That's going to be the next academic week. All right. Does anybody know what a system is, or has anybody heard of that before? System. If you read the title, linear equations. What do you think that means when you get an S on the end of equations? Yeah? Yeah, there's multiples. So when we're dealing with solving equations, we've always done 1 in the past. Well, now we're going to look at solving 2. Right? When you take algebra 2, when you get to junior year or senior year, whenever you take it, probably senior year, you'd be doing even more than 2. You can do up to 3 or 4. But we're going to focus on solving 2 equations, okay, at the same time. All right, so this is what we just said. For the rest of third quarter, we're going to be looking at systems of equations, also just called systems. I just went over the 3 ways that we're going to solve: graphing, substitution, elimination. You only have to worry about graphing today. That's it. So, start out with what is a system? So I said we're going to focus on 2 equations, but in general, a system is when you have 2 as a minimum or more. Okay, 2 or more linear equations. Now, if you look at the word linear, what word do you see in the word linear?
Line.
Line. So that means we're going to be looking at things that when you draw them, they make straight lines. All right? So the goal is basically we're going to draw 2 lines, and we're going to try to figure out where they cross. That's the whole goal for today, pretty much. It gets a little harder if things are curved. All right? We haven't really studied a lot of graphs in here, I don't think, that are curved. But curves are tougher, so we're going to stick with just straight lines. And when we have 2 equations, each equation is going to use the same variables. Okay? So just to show you, I'm going to come right back to this. But here's a problem. Equation 1 uses the letters x and y. Equation 2 uses the letters x and y. Both equations always use the same letters.
Hey guys, for the stuff we do for the next few, unless we're doing like a word problem or something where it's better to represent a variable with a different letter, everything we do will be with x and y. Everything you'll see on notes, homework, test review, anything like that will be x and y as the variables.
So when you have a system of 2 equations, I just said you're going to have 2 variables, usually like Mr. Roy said, x and y. So when we solve it, we have to find 2 things, right? Normally when you've got something like this, and the directions say solve, you solve for 1 thing. You get x, and you're done. Now we're going to have to get 2 things. We're going to have to get x, and we're going to have to get y. Right? So could somebody give me an equation that has x and y in it? It can be like the first one we did in the warm-up, where the y is already by itself, or it can be like the second one we did in the warm-up, where the y wasn't by itself. Either way. Yep?
15x plus 20y equals negative 16.
Perfect. Perfect. 15x plus 20y equals negative 16. So she gave me one where the y wasn't by itself. Can somebody give me another one where the y is by itself? Like the y equals mx plus b form. Like the first one that we graphed in the warm-up. Alex? Like the first, can you give me one like the first one in the warm-up? For the graphing?
He wants one where y is by itself. He wants it in slope-intercept form.
Y equals 5x plus 8.
Yeah, perfect. So that, we're not going to solve that one, but that's a system of equations. 2 equations, each equation has 2 letters. Perfect. Any questions on that? So when you're done, you'd have something like this. X equals, Y equals, and you'd tell me both answers. Or when you have an X and a Y value, what do we normally call that? When you have an X comma Y value in parentheses, what's that called?
Coordinate.
That's a coordinate. So there's a couple ways you can write your answer. You can just tell me the X and Y separate, or you can give me the coordinate where the two lines cross each other. That's the goal. So, solution. Okay, I kind of already said what the solution is visually. It's where the two lines cross. Right? But when you're finding a solution to a system of linear equations, you're finding an ordered pair that you could plug in, and it works in both equations. Right? And I'll use the ones up above, and I'll give you guys an ordered pair, and we'll see if it works in both. Okay, let me make one up. There's a coordinate I just made up, 1, 13. So if we wanted to see, is this the answer? Is this the correct X and Y value that solves this problem? This is how you do it. So to determine if a coordinate or an ordered pair is a solution, we're going to do the following. Let me move this up a little. All you have to do is plug in the ordered pair. Plug in the X, plug in the Y. That's why in the warm-up we had you guys plug in for 2 letters at the same time, because that's exactly what you're doing here. Plug the ordered pair into each equation and see if you get a true statement. Okay, an example of a true statement would be like 4 equals, what number would have to be on the other side if this statement was true? 4 equals what number? 4, yeah. That's a true statement.
On both sides.
Okay? If you get something like 4 equals 5, then that means the ordered pair that you have is not the solution. Okay, so we plug it in, see if we get a true statement. But notice it says right here, plug the ordered pair into each. You have 2. You have to plug it into each one.
It's got to work for both.
And if it works for one, well, that's good, but it's got to work for the other one too.
And guys, as you're doing this, as we're checking them, if you plug in for the first equation, those numbers, that coordinate, it doesn't work, stop. Don't do the other one. It doesn't matter. It's not going to work.
Okay, so let's just see if this one works. Okay. X is 1, Y is 13. See what happens if I plug it into the bottom. X is 1. X is 1. What's 5 times 1? 5. And what's 5 plus 8? 13. So yeah, it works in the bottom one. So this point does work in the bottom. Now if we try it in the top, I don't think it's going to work. If X is 1, what's 15 times 1?
15.
It's 15 plus, what's Y again in this coordinate?
13.
13. 20 times 13, that's going to be, what, 290 or something? 260? So that's 260. Well, 15 plus 260, does that give you negative 16?
No.
No. So what that means is you found a coordinate that worked in one equation, but it didn't work in both, so that's not the answer. Has to work in both. So that's all you do is you plug it in, see if you get a true statement. We're going to try a couple more of those right now. So the 3 options that can happen when you plug it in. It doesn't work in either of them. It could work in one of them, but then like Mr. Roy said, you got to check the other one because it's got to work in both. So it works in one, works in both, or it doesn't work in either one of them. Right? That's the 3 things that can happen. And we're shooting for works in both. That's what you got to have, works in both. So now they want to know if the given ordered pair is a solution to that system. So how do I check if that coordinate is a solution? What do I have to do?
So they might need a second because they gotta write that in.
Oh, they gotta write that in.
That's all. I didn't put it on there. So,
Okay, so your ordered pair is 2, 5. And the system that we're going to check is x plus y equals 7. And 2x minus 3y equals negative 11. So how do I check if that coordinate is the answer to both? What do I have to do? Plug it in, yeah. Which, Yusuf, what's the 2? Is that the x or the y?
X.
That's the x. And the 5? The y. Now, you said plug it in. Which one? The top one or the bottom one? The top one?
Yeah.
Just the top one?
No, both.
Yeah, eventually we got to do both.
Yeah.
But we'll start with the top one.
Yeah.
So x is 2, y is 5. Okay, so off to the side. I'm going to fill in 2 plus 5. Now I'm just going to put a question mark there because I don't know if this is going to work. And I got 7 on the other side. So the goal is for them to come out the same. What does 2 plus 5 give me? That gives me 7. I had 7 on the other side. They're equal. That means that works. So am I done? Am I done?
Oh, no, you have to do the bottom.
No, I know it works in the top one, but I got to keep going. It's got to work in both. Now, what if it didn't work in the top one? Do I need to check the bottom one?
Yeah.
No, why not?
Because it's both.
Right, it's got to work in both. So if it doesn't work in the top one, you might as well stop because even if it works in the bottom one, it doesn't matter. It didn't work in the top. Right, let's check the bottom. 2. And how about Ryan, what am I going to fill in for x in the second one?
2.
Yep. So I'm just going to call this equation 1 and equation 2. Equation 1, equation 2. So he said plug in 2 for x, okay? Minus 3 times, what am I filling in for y?
5.
We're filling in 5. Okay, I'm not going to put an equal sign because I don't know. I'm going to put a question mark. And I'm going to put negative 11. So you never have to do anything with the negative 11. You just leave it. Right? 2 times 2 gives me 4. 3 times 5? 15. Now, why didn't I just do 2 minus 3? Why did I do 2 times 2 first? And yeah?
You have to do the ones that are in parentheses first.
Yeah, we always follow the order of operations, right? If there's parentheses, multiplication comes before subtraction. All right. 4 minus 15 gives me how much? Negative 11. What's on the other side? Negative 11. They are equal. So that means that that coordinate works in both. So is it the solution or no? What do you think, Matt?
Yeah.
Yes. Tell whether the ordered pair is a solution. The answer here, yes. Now, when we draw these, they're linear. So what shape are they going to be? Lines, right? If you have 2 lines and they're not the same, how many times can they cross each other? 2 lines that are not exactly the same line. Think about if you draw any 2 lines, right? Like in an X
they
shape.
can only cross where? How many times can they cross? Once.
Once, right? So when you find a solution to a system of linear equations, since lines can only cross once, there is only one coordinate that would work in both. You'll never find another coordinate that works in both. Like if you try, you're like, well, what about like 4 and 3? 4 plus 3 is 7. Yeah, but if you try it in the bottom one, it won't work. There's only one answer to every problem we do. And this one is 2, 5. That's the one answer. So eventually, you're going to have to find this answer yourself. Okay, we're going to show you how to do it. Okay, but for now, we're just giving you an answer and having you check and
Giving
see
you
if it
the
works.
works. You don't have to graph it. So guys, for this one, why don't you take a minute and just first off, write the example, and then just plug in.
Alright guys, let's take a look at the one that you guys just plugged into. First thing, can somebody just tell me what am I filling in for x? Yusef?
You're filling in the -2.
And what am I filling in for y?
0.
0. Okay, so when you do, just call these equation 1 and equation 2. When you do equation 1, you should have had 0. I'm going to put a question mark because I don't know if it's going to work yet. Equals, or a question mark. -2 times, and now fill in what Yusuf just said for x. -2 minus 4. PEMDAS, first thing is multiplication. What's -2 times -2?
4.
4. What's 4 minus 4?
0.
0. So far, so good. 0 equals 0. Can we stop? Do we have enough information? No. If it didn't work, we could stop. But it did work, so we got to keep going and check the next one. All right? So let's check it.
So that one is not a solution. That makes sense?
Okay, second one. Y equals -x plus 4. Y, I'm going to put a question mark. -x plus 4.
So x
What?
would be
X is -2, and they want me to put in -x. So what do I put in? Right, it's like -2, which is like +2.
Oh.
Right? -x, -2. What's 2 plus 4? 2 plus 4? 6. No. 0 does not equal 6. So the answer here, is that a solution? No. It didn't work in both, so we're good.
There's a C, Mr. A, right?
I know you
can
can.
skip it.
Yeah, I think we're good. I just plugging it in. You guys saw what happens when it works. You saw what happens when it doesn't. Okay.
The only thing that's going to be different is where those letters are, you're putting numbers. All right? So guys, in these, in 1A, and we didn't do 1C, but it did work out. So if we graph these equations, they'd be like we talked about. We're doing linear systems. We already said a couple times it's going to be straight lines. All right? And we talked, how can a coordinate be on two lines at the same time? Like we just talked about. If the coordinate is the location of where the line crosses. We just said if you have two lines that aren't in the same spot, all right? They're not one on top of each other. Yeah, they're going to intersect a whole bunch of times, the whole time. But if you have, like Mr. Hager just drew, if we have two lines and they only cross in one spot where the line crosses, all right? So what we just did before was we gave you the coordinate. We gave it to you, plug it in, see if it's a solution or not. Now we're going to have to graph the two lines, figure out what the coordinate is, and then check and see if it works. In terms of solving systems, guys, graphing is probably it's probably the worst way to do it because it's the most time consuming. You have to graph two lines, figure out where they cross. But again, we just have to, we're only spending one day on this because it's time consuming to be able to graph the lines. And plus, you got to make sure you're really confident about being able to graph the lines too. All right, so we're going to look at three things here, 3 steps to solve using graphing, solve systems using graphing. What we did before was, the first couple of examples we did, we gave you the coordinate. You didn't have to do any graphing, we just gave you the coordinate, plug the numbers in for x and y, see if it works. Now we have to find that coordinate by graphing. All right? So on your guided notes, first thing we're going to do, graph each equation in slope-intercept form. So to be able to solve, what we did before, guys, when we gave you the coordinate, it didn't matter if y was by itself. You can just plug it in and do it. So if we give you the coordinate, it doesn't matter what format it's in. You can just plug the numbers where the x and the y are and solve. If we're solving by, if we say you have to graph these two lines, then you've got to make sure that each equation is in slope-intercept form. They both have to be in y equals mx plus b. In both equations, y has to be by itself. 90% of the time, guys, for the stuff we do this week, y will be already by itself. It'll already be in slope-intercept form. You can just go ahead and graph it. All right? We probably won't get into having to rearrange anything. We might, but chances are we probably won't. So make sure it's in slope-intercept form. Y equals mx plus b. Next, estimate the point of intersection. What that means is you have to go look where the two lines cross and figure out what coordinate that is. So count left or right on your x-axis, all right? Because x always comes first in the coordinate. Count left or right. See where it is. Okay, so I'm looking at my dot. I'm looking at my coordinate. All right, it's on 3 on the x-axis. Then I'm going up 5. So my coordinate would be 3, 5. So this is new now. That we have to find the coordinate. Before we gave it to you. An example 1a and 1b. Now we have to find it. So we have to graph the two lines and figure out where they cross. Third thing is what we already did. So these two steps are actually graphing the lines. That's new. I mean, we've graphed before, but we never had to find out where they intersect. Third thing, now like we did in the first two examples, 1a and 1b, you'll have your coordinate. Right, you figured it out. Plug it in, see if it works. Like Mr. Hager talked about when he did those first two examples. You can have 3 things, all right? It'll either work in both. That means it is a solution. It'll work in one, which means it's not a solution. Or it won't work in either of them. Then again, it's still not a possible solution. So those are your 3 steps to solve by graphing. Slope. So again, we need to know. This goes back to kind of like before, like Thanksgiving time. We need to know how to be able to graph. We need to know, when we do slope-intercept form, where do we start? Where do we go? Those type of things. People okay with this? Chris, I'll go like this for you, buddy. How's that? All right. So here's our first example. So first thing we have to, we're solving by graphing. What's the first thing we have to make sure? Someone tell me by raising their hand. What's the first thing we have to make sure of? Yusuf?
To see if like it's a plug-in actually on the questions.
We're going to make sure it's in slope-intercept form, which means what? That's a fancy way of saying what, Donovan? Y has to be by itself, right? Y is by, so we're going to make sure Y comes first, equal sign, number with X, then just a number at the end. Do we have that in both equations?
Yes.
Yeah, Y is by itself in both. Good. So, first one. Where am I going to start? The jelly, that first equation, where am I going to start? At what number? At what number and on what axis?
Well, we're going to start with the lines. The first equation.
Okay, I want to graph the first equation first. I agree. I'm graphing it now, right? So when I graph it, what number do I start at and on what axis? Because remember, I want to put it in slope-intercept form, right? So you have a choice. Am I going to start at the slope or am I going to start at the y-intercept? No, I'm going to start at the y-intercept. So in this problem, Dylan, the top equation, what's my y-intercept? What number is my y-intercept? 1, right? So if it's the y-intercept, I'm going to start at 1 on what axis? The y-axis. Start at 0, right? Then go just to 1, right? Okay. So once we use that 1, we're done with it. Once we use the y-axis, we're done with it. The y-intercept, we don't have to come back to that. So if you want to, I've used that for what I need it for. I'm done. Now, David, from that y-intercept, where am I going to go?
Up 1 over 1.
Up 1 over 1. Even though it's not written there, right, we know, like David just told us, there's a 1 there. And any whole number, we've talked about this too, we want to put it over 1. -5, -7, 8, 3. Whatever numbers with x, if it's a whole number, just put it over 1. Because remember, slope is rise over run. We're going up or down first, and then we're going to go almost always to the right. Whether it be up to the right or down to the right. We always go to the right. In what situation would we have to go down? Someone tell me by raising their hand. In what situation would I have to go down? Yusuf?
It was like minus.
Yeah, if the number with x is negative. In this case, it's not. It's positive. So like David said, up 1 over 1. Guys, when I'm solving by graphing, I like to go, whatever the slope is, I want to do it as many times as I can. So I want to see with that other line. It makes sense when I graph the other line. So I'm going to do this as many times until I go off the page. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I'm just going to do it as many times until I go off the page or go off the graph. All right? Now, mistakes, at this point, if you want to draw the line and connect the dots, you can. You don't have to, all right? But you can. Because what I like to do is I'll graph the next one, and I want to see where 2 dots are going to land right on top of each other. Because that's going to be my coordinate. Okay, so my next one. Nathan, where am I going to start my next equation right here, my next linear equation? Where am I going to start? At what number?
-5.
-5 where?
On the y-axis.
So where do I go?
Down 5.
Down 5. Mr. Am I good to graph?
Yep.
I'm going to go down 5. Like Nathan just said, 1, 2, 3, 4, 5. There it is. So again, I've used the -5. Nathan, -5 is the what in that problem? Y-intercept. I've used it, it's gone. I don't have to worry about it anymore. The negative goes with it, it's done. Now, Haley, from there, where am I going to go? Up 3, then where? Over where? Over. What did I say? If I have a whole number with the slope, what can I do like I did up here? What did I do up here for this? I just had an x, so I put a 1 with it, so I knew there was the number 1 there. What else did I do? I put the line, and I put a 1 on the bottom, right? So what should I do with this 3? Put a line, put it over 1. So that's telling me, like you said, go up 3, then where? Which direction? Always to the right. So Haley just said, now, I'm just going to keep, the first time I put my point, I may not end up on the other line. I got to keep doing my slope until I end up on a point on the other line. So I'm going to go up 3, 1, 2, 3, over 1. Do it again. 1, 2, 3, over 1. 1, 2, 3, over 1. There it is. There's my point. So you guys see how I do it? When I went up 3, right 1, I didn't end up on the other line. You may have to put a couple points using your slope until you find, in this case I had to do it 1, 2, 3 times until I found the point where the 2 lines intersect.
It might not happen every time.
Yeah.
It might not.
You may not get it. You may not get something like this. That's okay. That means that it's just no solution because they don't end up right on top of each other. All right? So it's not always going to work out this way. 85% of the time, guys, we'll give you 2 linear equations where the lines cross. All right? But it might not happen right after the first time. You may have to do the slope a couple times until they intersect. So now someone tell me, what is that coordinate? What, comma, what? Gigi?
3, 4.
3, comma, 4. Let's see. 1, 2, 3. Yeah. 3. And then up 4. 1, 2, 3, 4. Remember, x comes first, y comes second. X goes across, y goes up and down. Now I'm gonna do like I did before. I gotta use this coordinate and see if it works in both equations. Right? So we're at the point now where we've done this part. The graphing was new. I mean, using slope-intercept and that kind of stuff, we've done that before, but actually finding the point where they cross, where they intersect, that's new. But this part here, we're given the coordinate, we did that in the first two examples. So someone tell me, what's that, what am I going to write for my first equation, plugging in x and y? What's that going to look like? When I plug in x and y for the first one. What's that going to look like? Nicole? 4 equals 3 plus 1. Y is 4. X is 1. That's how I got that. When I'm at this point, guys, chances are you don't have to do any, you don't have to move anything around. Don't go, okay, I want a -1. Don't do that. Just do the arithmetic. That's all you have to do. You don't have to move anything in this case. 4 equals 3 plus 1, guys? 4. So that checks out. So I got to keep going, right? I got to see if the other one works. Someone tell me now. Again, I got 3, 4 as my coordinate, right? What's my second equation going to look like with x and y plugged in? What do you think, Garrett? What's my second coordinate going to look like with x and y plugged in? Well, here it is. Here's my coordinate. Where I see these letters, I want to put these numbers. Everything else stays the same. So I can still put my equal sign. I can still put a 3. I can still put a minus. I can still put a 5. Those things stay the same. Those don't change. The only thing that's changing is where the letters are. I'm going to put numbers. So the first letter was y, right? What's taking the place of y?
X.
What number is going to take the place of y?
Oh, 4.
4. I'm going to put parentheses next to the 3 here. Leave a little bit of space. Because that's where my x goes, right? What's taking the place of x?
3.
3. So again, I see some of you guys doing this. You'll put 4 equals 3 minus 5. That 3 is not taking the place of this whole thing. It's only taking the place of the x. The numbers and the signs that are there, those stay. The only thing that changes is where the x and y are. You put numbers for that now. But the numbers, the signs, that stuff doesn't change. That stays there. That's why I kind of wrote that stuff first so you could see how it changes. All right? So now, bring my 4 down. 3 times 3. What is it, Chris?
9.
9. I'm going to bring down my minus 5. Again, don't make the mistake of trying to add 5 and do that stuff. There's no variables here. There's nothing you have to move around. Just do the math. Bring my 4 down. 9 minus 5, Miguel? 4. It happened to be 4. We happen to have the both 4 equals 4, 4 equals 4 in both equations. It's not always going to work out that way. It just did on this one. Yes. So 3, 4 is a solution for this equation, for this system. All right? So again, the new piece was the graphing part. Plugging it in, we've already done. All right? Let's take a look at the next one.
Want to do the word problem and come back to that one?
Up to you. Okay, that's fine. All right, so guys, all we're doing, we'll get into probably in a couple, like in a month from now, we'll get into doing some word problems with systems. But for the sake of this problem, all we're doing is setting it up. We're not solving, we're just setting up a system. There's no, because we're not going to, these numbers are so big, we don't want to solve them by graphing, right? That's why graphing is not a good way to solve systems. It's a good way to start, but it's really not the best way to solve systems. Because if I get a big number like 144, I don't want to have to graph that on a coordinate grid. It's too big. All right? So you sell small candles for $4 and large candles for $6 for a total of $144 at a craft fair. Okay. So again, for a system, what do I need? To be able to set up a system of equations, what do I need? Someone tell me by raising their hand. Well, I need a couple things. That's one thing I need. Donovan?
Slope-intercept form?
I can put in the slope-intercept form. I don't have to, but I can. So in slope-intercept form, what do I have?
X and Y.
X and Y. So I need an X and a Y. All right? I'm just going to keep it consistent. For this problem, I'm going to use X. I'm going to use Y. What do you think X is going to represent? Because we're doing a word problem now, so those variables represent something in the word problem. What do you think the X is going to represent? Small, like you said, this said, we're dealing with two things here. Small candles and large candles. All right? So, like Yusuf just said, X is going to be small candles. How did I determine that? It was the first thing written in the problem. All right? I'm going to say that my small candles are X. What's Y going to represent then?
Large.
Large. Large candles. All right. So we're trying to find. We know the price. We just don't know how many we sold. All right. So what? This X is going to be attached to something else. What's the X going to be attached to?
Price.
Which is?
What is it? X.
For small candles.
Oh, 4.
$4. So equate. Mr. Hager is writing an equation when he's making it neat. So equation 1 is going to be 4x. Again, because they're $4 and they represent small candles.
Think about if you sold like 3 candles and they were $4 each. You'd multiply, right? If you sold 3 candles and they were $4 each, 3 times 4 is 12. Well, we're saying we sold X candles. So 4 times X is how much money you made in small candles. Just fill in how many you made. But we're not going to solve it.
So Paige, if small candles was 4x, what about large candles? 6. Well, x is going to be small. Y. I'm going to leave a little space. 6y. What's the other number we're going to need for this first equation? We use the 4. We use the 6. 144. It's the only other number here we have. The first sentence is the first equation. 144. Now I'm going to put a couple boxes here. I put 2 boxes because in those boxes there needs to be some signs. What sign's going to go in the first box?
Plus.
Plus, right? Because we're combining the amount we sold. Right? And tells me to add. What do you think is going to go in that second box? So we did small candles, 4x, large candles, 6y, and this plus for a total of $144. Total. Yes, Yusuf. Total is equal, or was, it's always equal. Here's my first equation. Done. All right? So this first sentence is done. I don't need it anymore. I used it, I set up my equation. Second, you sell, Mr. Hager kind of broke it down over here.
I just worded it a little differently, but it means the same thing.
Large candles, so whatever letter we're using to represent large candles, is for more than small. So large candles, what's representing large candles? Y, like Donovan just said. Y. So large candles, I just used it, is Y. The next thing, Mr. Hager kind of rephrased this, the next thing is what? The next thing written after large candles is what?
Large.
Did it? After large candles it says what?
Is. Oh, is.
What? Good, Haley. Equals. What's going to come after? So I just did is. Brady, after is what? 4. What do I write? 4. More than. Plus. and just going through step by step, writing in what those things represent. More than small candles. What's small candles? What we're using to represent X. All we know about small candles right now is X. There's my two equations. I'm not solving that now. All I'm doing is setting it up. I don't have to do any more than that. All right? Because tomorrow we could solve this. All right? This would be better to solve using substitution because I got 144. If I rearranged everything here, all right, my y-intercept wouldn't be 144. It'd be a little bit smaller, but not much. And then I gotta get a big, huge graph and find the y-intercept. That's why graphing is good for like if you have smaller numbers to solve systems. If you're getting the bigger numbers and word problems, that kind of stuff, we'll use other methods. All right? Guys, let me just. Everybody's good with this?
Yeah.
Okay. So we'll probably give you guys the rest of the class to just kind of work on stuff. Couple things. All right?
Vacation.
Yes, last week before vacation. All right? Now, they're talking about, let me get through this first. We're going to miss part of class on Wednesday. Right? In a small, like half an hour. We got the motivate. You guys watched the movie last week, Catch Me If You Can?
Yeah.
The guy that Leonardo DiCaprio played, Frank Abagnale, he's coming here to talk to you guys on Wednesday. We are staying in this room. We're going to watch it on, so you might be able to get it up on here.
I can't.
Yeah, we'll get it up on the smart board. You'll be able to watch his presentation. He's going to come to speak to us. Now, they're talking weather on Wednesday. Talking some snow on Tuesday. So I don't know what will happen on Wednesday. Regardless of what happens. So let's say if we have an early release on tomorrow. They let us out at like 11:30. We will still have the test on Friday. If we have an early release tomorrow and maybe 2-hour delay on Wednesday, we'll still have a test on Friday.
Okay.
Regardless of what happens weather-wise, we're testing on Friday because we have a review day on Thursday. So if we miss some time, we can always catch up on Thursday. All right? So just understand, we're going to miss some time. If there's a 2-hour delay on Wednesday, guys, I don't know what they're going to do with the motivational speaker. As soon as Mr. Hager and I are here, we'll let you guys know. Review day on Thursday. We may have to play a little catch up on Thursday because we may miss some time because of weather. All right? Mr. Hager and Mr. Roy will both be after school on Thursday. Some of you guys, it's important. You saw you know your second quarter grade now. We're halfway through. Some people in this room are in the fail. If grades close today for the year, they'd have to go to summer school to make up math. All right? You guys know who you are. Start staying after school. We can get your reference sheet ready. We can do some more practice. There's no reason why anybody in here should have to go to summer school. All right? Stay after school. Take care of what you're going to take care of. That way you can be where you want to be. All right? And then our second test of third quarter is on Friday. So it'll deal with graphing. It'll deal with, we'll give you the coordinates. You're going to plug them in. And also the stuff we do the rest of the week, which is substitution. All right? So let me go back. I can. To do this one right now. So solve that one by